Okay, Calc kids, we're going to take a look here at notes for section 7.3, dealing with revolutions, volumes by revolutions. Okay, so let's see if we can get our PowerPoint going. Yep, there we go. And you don't see me. So find the volume. Here's go. We got a volume of a right circular cone here, our radius or our y value, and looks like it's one unit tall, and the radius is 3. So we're going to do the integral of pi r squared dx, but you can't have r and x in the same equation. So r is actually your y value, okay? And we're going to use y squared dx from 0 to 1. But what is y? Well, we have to set up similar triangles because each circle is based on that triangle that we have. So you can do x over y equals 1 over 3, or x over 1 equals y over 3. Either way, you still get the same equation, 3x equals y. Be able to go through and do that. Okay, so now what's y? Well, we have to square it. So we need to go there we go. Pi times not y squared now, but 3x, the quantity squared, dx. So that's going to be 9x squared. You can pull the 9 and the pi out and integrate x squared, which would be x to the third divided by 3. Simplify you'd like, but either way, you still have to put 1 in there. And then you get 3 pi, and you put 0, you get 0, so your answer is 3 pi. Okay? So we're revolving circles around the x-axis in this case. But my radius turns out to be y, but y has to be written in terms of x because we've got a dx. We're going to stack these circles from 0 to 1 to be able to go through and do that. Okay? Here we go. Here's about the same thing again. Radius is 3x. We got a bunch of circles. So again, it's the same type of thing, but just a little bit different. Okay? We're not doing the geometry, but in a sense we are. And you still go through and set it up the same way. Your radius is y, or y is your radius, but you're stacking our circles from 0 to 1, and that's a dx value to be able to figure that out there. Okay, find the volume of a cone that's formed by x squared plus 1 from x equals negative 1 to 2, revolved around the x-axis. So if you take a look, it's going to look like this is a graph. The parabola opens up. The bottom of it is at the point 0, 1 from negative 1 to 2. So you can see the tick marks on there. And then we're going to revolve it around the x-axis. So if you do that, then we get this. Now put a top and a bottom, or in this case, a left and a right on it, and you've got a circular function there. Okay? It's going to kind of look like that. Okay? Tilted a little bit differently, but basically the same thing. Okay? And then if I cut it away, you can see that x squared plus 1, and then it's revolved around the x-axis. So that's why down here in the lower right-hand corner, there's your curve from negative 1 to positive 2. Okay, and I actually made this on a 3D print program that we use in IED class. You can use it called Fusion or Autodesk Inventor. Okay, and there's the volume. It actually gives the volume for you. And in this case, it's going to be 49.009 cubic inches. Okay, but how do we do the calculus on it? Well, that's going to be the integral from negative 1 to 2 of pi times r squared, but r is y from the x-axis because we're revolving around the x-axis, and dx because that's where we're stacking our circles from negative 1 to 2. Okay, but what is y? Well, that's the x squared plus 1. So that x squared plus 1 takes the place of y. We still have to square it all out. X to the fourth plus 2x squared plus 1. And then we can go through and integrate that. X to the fifth over 5 plus 2x cubed over 3 plus x. Evaluated at 2 and at negative 1, you get that. And then we'll simplify that a little bit, get that answer there. And notice the answer is still the same. Whether it's done with the graphing portion or a 3D print type program, or we do the calculus down here. This is an exact value. 49.0088 is the calculated value. You had to use a calculator to get that. Okay, so that's how you revolve around the x-axis there. Just remember, your radius is like a y because it goes up and down to be able to go through. Let's go a little bit harder. Find the volume of a figure when that same equation is revolved around the line y equals -2 from 1 to -2. Okay, so what is that going to look like? Now we've moved, we're no longer revolving around the x-axis, we're revolving around another line, y equals -2. So we've got a bigger or thicker type of object that we have. Okay, there's the cross-sectional view of it. And this is what it looks like with part of it cut away. So you can see where the axis is for rotation, and it's right there. So how do you get that answer of 162.106? Well, we need to do a little bit of calculus. I times r squared, because there are a bunch of circles, but the radius is in terms of y because it's going up and down. Okay. Now for this one, we have to take your equation, x squared plus 1, and then minus a -2 from it. Why? Because it's the upper minus the axis of rotation. Before, we took the equation -0, which doesn't really change anything. But now we need to find the distance from our curve to the rotational axis. That's why you minus, and it turns out to be, in this case, -2. Okay? Do a little bit of simplification on it. Okay? Remember, it's the upper minus the lower. Do a little bit of algebra on it, and then go ahead and integrate it. And then evaluate it at 2 and at -1. And you get your answer of 51 3/5 pi, which, if you do that on the calculator, turned out to be 162.106. Okay? Just remember, you have to take your big R, which is the outside, minus the axis of rotation. I call that the little r right here. Okay? Because you want that total distance to be able to go through. Now, let's go through it again. This one's still revolved around the y equals -2. This time we have a hole in the middle of it. Okay? So you can see the upper and the lower, it's revolved, the black stuff in the graph there. So it's going to look like that with a hole in it. Okay? So you want to do, there's our answer from the 3D print program. So it's the volume of the big one minus the small one. Okay, so pi r squared minus pi r squared. Now, if you want to do it as two different integrals, you can do that. So the first one looks familiar because we just did that one. Minus pi times, and we want to go from -1, or we want to, from -1 minus a -2. Bore out a 2-inch diameter circle. Okay, we're at -2, so you can move 1 up. -1 minus a -2. Okay. And then we're going to subtract it because we don't want to count that. We're going to actually bore out or cut out the other portion. It's still the upper minus the lower. Okay. And remember, we wanted a diameter in the middle that we're going to bore it out or drill it out. So the radius is 1. We go through and work this out here. We can factor out a pi from each one of them. Then we're ready to integrate. And then evaluate it at 2 and at -1 to get our answer there. Okay, so those are the three basic revolutions we have. The normal one around the x-axis, the other one around y equals -2, and then what happens if you have a hole in the middle of it. Okay, Well, what about this one? X equals the square root of y. Well, that's y equals x squared. And from x equals 0, let's see, and x equals 0, that's the y-axis. From y equals 1 to 4, revolved around the y-axis. So it's going to be a little bit different. It's going to look like a little cup, flat bottom on it. Still going to do the radius, but this time we're doing dy instead of dx's. This one actually turned out to be a little bit easier. But we are going from 1 to 4, not 0 to 4. It'd be a hard glass to hold up, but from 1 to 4. So we've got a flat bottom on it. Okay, and evaluated at 4 and evaluated at 1. So you get 16 divided by 2, or 8 pi, minus 1/2 pi, which is 7.5 pi. Okay, a little bit different, only that we're doing dy instead of dx. You can revolve around either one of those two axes. You can actually do others. They're a little bit harder. We're not going to get into that. And there's the actual answer decimal-wise from the 3D print program. Okay, here's your homework. Good luck. Work together, ask plenty of questions, and we'll see you again.